Okay, we're going to talk about on Unit 6, Day 3, graphing. And a lot of the principles that we've used earlier are going to come into play here. Here is our function. Here is inside our function, and here is outside our function. So since A is outside our function, that's going to stretch the graph up and down. We're going to call that the amplitude, and it's always positive, and so whatever this coefficient is, the absolute value of that's going to be the amplitude. This is also outside the function. That's going to be the vertical shift, and what we do is we shift the midline of the graph, the middle of the graph, and so the middle of the graph will be the shift. And then the B is the shrink or stretch for the horizontal shape. We're going to call that the period, how long it takes for this thing to repeat over and over and over. It could be faster or slower depending on the B value. And then C is our horizontal shift. Notice that we have to factor the B out of the X, so we get the shift separate from the period. You have to separate them by factoring. So looking at this diagram, here is our parent function sine, which we need to know. That's one period of it. It does keep going, like all these other functions. The period is how long it takes to start over again. Once you've seen one period, you've seen them all. The amplitude is the distance from the midline, and distance is always positive, hence the absolute value. The sine curve has been shifted to the right from the original beginning point, and in this case, since the x-axis is down here and the midline shifted to there, this is the vertical shift. So first of all, we have a cosine graph. So I look at this graph and I go, if I start here and I go down and back up and stop here for now, I'll have one period of cosine. So then, if this is the midline for our cosine, I'm going up to and down to from the midline. So there's our amplitude, and we put it where the A value goes. For cosine, the period is from one high point to the other high point. And so if I go left 1 and right 7, this must be 8. Since the typical period for cosine is 2 pi, and B is our scale factor, 2 pi over B is what the new period is going to be. The new period is 8. So I want to solve for B. So I cross multiply across the equal sign, and I get 2 pi on one side and 8b on the other. To solve for B, I have to get rid of this 8, so I have to divide both sides by 8. And so B is 2 pi over 8, reduce 2 over 8 to 1 over 4, and B is pi over 4. And the B goes here, inside the brackets, outside the parentheses. It's factored out. So C, the horizontal shift, this graph moves to the left 1. So let's say that the C value is -1, because I moved the graph to the left 1. But in my formula, it's subtraction. So if I have x subtract -1, that should be x plus 1. So you're right, there was a mistake on my notes. We found it. And then we see that the midline used to be on the x-axis, but now it's moved down 1, so the d value is -1, and that's the end of the equation. That was so much fun for cosine. Let's do it for sine. So again, what you need to do is go, okay, let's have sine start in the middle, goes up and down and back up to the middle. There's one period for sine. We have to know what the parent function looks like. So here's our midline. So our graph goes up to and down to from the midline. So that's our amplitude 2, and that goes in this position where the A is. For sine, the period goes from the middle to the middle. So to the left 3, to the right 5. So this whole thing must be 8. So like the previous problem, if the period is 8, and period is normally 2 pi, but it's over b, and I have to find b, cross multiply 8b equals 2 pi, divide both sides by 8, b is pi over 4. So that's the b value that changes the period from 2 pi to 8. This time we shifted the beginning of sine to the left 3, call that -3, and this one's right, left -3, but our form is x subtract c, so if I have x subtract -3, that becomes x plus 3. And then if from the midline I go down 1, the d value is -1, I go down -1, that's outside the jurisdiction of the function. In example 4, we are given a model of a situation, temperatures over the course of a day. So let's kind of do a rough sketch. First of all, this is outside the function, and so that must be the vertical shift, so the midline goes up to 85. The amplitude is 15, but there's a negative here, which means we flip the graph. So the cosine curve doesn't start above, but it starts below 15. So 15 below 85 is 70. And then it's going to go up 15 above that, so that's 100, and then come back down to 70 again. So do you see that it's a cosine graph flipped upside down because the number in front of the cosine is negative? It's going to go up and down 15 from the new midline of 85. So the high temperature is 85 plus 15, which is the midline, plus the amplitude. Hope that makes sense to you. The midline plus the amplitude, and the low temperature is going to be 85 minus 15, or 70, which is the midline, minus the amplitude. You don't have to memorize this. I'm hoping it just makes sense. And amplitude's with a P, isn't it? So period, we know is 2 pi over b, and b is the coefficient of the variable inside the function. Normally it's x, but since here we're talking about time, the variable is t. So the number in front of the t is pi over 12. Dividing by pi over 12 is the same thing as multiplying by 12 over pi, times 2 pi. Pi over pi is 1. 2 times 12 is 24. Since we're talking about course of a day, I'm thinking this 24 means hours. And if it is, this does make sense. So that from here to here is 24 hours. So we sketched the graph roughly already. Let's now do it in detail. We said that this is the shift of the midline, so the midline is now here at 85. We said this is the amplitude, and this flips the amplitude. So cosine usually starts high, but now it's going to start low, 15 below the midline, and it's going to go 15 above the midline at its high point. Now, we said that the period is 24. Well, here's 0, here's 24, so here's our period where it starts and ends. So it starts at a low point because the cosine is flipped, and it ends at a low point because the cosine is flipped. Well, halfway between the two low points must be the high point at 12. So that's where the top of the amplitude, you might say, goes, where it goes up to 15 there. Well, halfway between 0 and 12 is 6, and the scale is 2, 4, 6. Shouldn't that be where the middle is? And the same is true on this side. So at 6 and at 18, so it's 6 plus 12 is 18, 18 plus 6 is 24. Every 6 hours, we hit a middle. So 0, if it's midnight, is here. And yeah, at midnight, it's possibly the coldest, give or take a few hours, because it's the middle of the night there. Let's see, what's that? 12. Well, 12 noon, the highest, give or take, depending on the region and weather. Now they want us to do sine. Well, to do sine, you have to visualize where sine is. Wouldn't sine start here, in the middle, go up, down, and back up again? Well, a lot of is the same for sine. But if I start here, it's normal. It goes up, down, and back up again. So the amplitude of 15 is going to be positive. It's still going to go up 15 and down 15 from the midline. The number that controls the period is going to be the same because it's still 24 hours. So the b value is still going to be pi over 12. And the midline is still going to move up 85. So that's not going to change too much. That's going to change it all. That's not going to change it all. But sine should start on the y-axis. It starts over here. So that's to the right 6. To the right 6. Remember, subtraction is part of the formula, so it's minus a positive 6.